Hi, I'm Ms. Fung. Today we're going to look at general solutions in circular functions. So recall that these are the type of questions we did previously. Sine x equals 1 over root 2, where x is between 0 and 4 pi. How do we find all the solutions for sine x equals 1 over root 2? Well, we had a look at the graph to visualize it, and we saw that the first solution was, well, sine x equals 1 over root 2 when x is equal to pi and 4 from our two triangles. And we know that it's positive, so sine is positive in the first or station 2 cofield, so the first and the second quadrant. So after obtaining our first quadrant angle of pi and 4, we found this other solution by looking at the quadrants. So we have pi and 4, and that one is pi minus pi and 4, which is 3 pi and 4. After obtaining these two solutions, we have to obtain the other two, and to do so we notice that it is one period away, so we added a period to both of these. So pi and 4 plus 2 pi is 9 pi and 4, and 3 pi and 4 plus 2 pi is 11 pi and 4. And we obtained our four solutions in that way. Today we're going to ask the question, what happens if instead of having 0 to the domain being between 0 and 4 pi, we want all solutions? So how do we do that? How do we get all solutions, or in other words, R? So let's have a look at that. So here we have the working out from before. What happens if we want not just the first 4, but we keep going? Well, if we keep going, it's like saying adding 2 pi over and over again, or in other words 2 pi times n, where n is any whole number. And it works for this one as well, because if we substitute n equals to 0, we would get pi and 4. So this is the general solution for all of these ones, not that one, all of these ones. And we can write it as 2 pi n plus the angle that we want, so pi and 4. So that gives us all of those solutions. Now how about that one over there? Well, we are 3 pi and 4 plus 2 pi, so we could say plus 2 pi n. And we noticed that 3 pi was written from here, which was pi minus pi and 4. And if we wrote it that way, then we can see that we can rearrange the whole pi's together to have pi plus 2 pi n minus pi and 4, and we can write that section there. We can take out a common factor. What's that? It is pi, so we can write it as 2 pi plus 1 pi minus pi and 4. And we wrote it so that it's more similar, the setup. So we can write the formula as 2 pi n plus inverse sine of 1 over root 2 and 2n plus 1 pi minus sine inverse of 1 over root 2, because that's equal to pi and 4. So we can summarize that to say that for a between -1 and 1, the general solution of the equation sine x equals a is going to be 2 pi n plus sine inverse a, or 2n plus 1 pi minus sine inverse a, where n is integer. So a is your 1 over root 2 in the previous question. We're going to look at cos as well, and for the cos, what is it going to be like? Let's have a look. So in the previous video we saw that for cos is equal to a half, we can work out that the first quadrant angle using the triangle is pi and 3, and we know that cos is positive in the first or station 2 cofield and the fourth quadrant. So we did pi and 3, and then we did 2 pi minus pi and 3, which is 5 pi and 3, and to obtain the other values we added periods. So to add a period to that, we obtain pi and 3 plus 2 pi, which is 7 pi and 3. To add a period to that, we have 5 pi and 3 plus 2 pi, which is 11 pi and 3. Previously we didn't count that because it wasn't part of our domain, but today we're going to look at what happens if we change the domain to everything. This pi and 3 plus 2 pi can be written as pi and 3 plus 2 pi n, because we can have multiple of that. and then we can simplify it and rewrite it in the same order as before, 2 pi n plus the angle we want. And for this one, we can do that part plus 2 pi. And we notice that 2 pi and the 2 pi will cancel each other out, so we can just write 2 pi n. As in, like, if I have n equals to 2 or 3, it will be the same as adding an extra 2 pi. So we can just omit that first 2 pi and write 2 pi n. So now this one is a lot simpler. You can see that we have 2 pi n plus cos inverse of a half, or pi 3, and we have 2 pi n minus cos inverse of half, which is pi 3. So this time you can see that they're very similar. So for sine, it was a little bit tricky because it was 2 pi n plus sine inverse a and 2n plus 1 pi minus that. But for cos, it's just 2 pi n plus and minus cos inverse a. So try to remember that because we're going to use it. We're also going to do tan, but instead of going through the explanation, I'll just give you what it does. So the general solution for tan is just pi n plus tan inverse a. And we know it's pi n because the period is only pi instead of 2. So remember, it's the period for sine and cos is 2 pi. So you can see the 2 pi in the general solution. Sine has 2n plus 1 pi in there because it's positive in the first and second quadrant, whereas cos is positive in the first and the fourth quadrant, so we have that, and tan is just pi because of the period. So let's do an example. Find the general solution of sine x equals a half, and we know that from the previous slide that the general solution is these two patterns there, so we're just going to use that this time. So we're going to plug it in there. So it will be 2 pi n and then sine inverse of a half, and it will be 2n plus 1 pi minus sine inverse of a half. And we know that sine inverse a half, when is sine equals to a half, that is pi over 6. So we write that out, and so we can write that out with the pi over 6 over there as well. And don't forget to write comma, n is an integer. One more example. Find the general solution to 2 cos x equals root 2. So now there's a 2 there. What do we do with it? We are going to move it to the other side. So now cos x root 2 on 2, we know that x is equal to pi on 4. Now we use the general solution from before where 2 pi n plus or minus cos inverse a, and we plug in our values, so that section there becomes pi on 4, and now we have 2 pi n plus or minus pi on 4 where n is an integer. You can write plus or minus, or you can write them separately like that. Doesn't really matter. Example 5. Find the general solution to root 3 tan 3x equals 1. So we're going to do the same thing before with the root 3. Bring it over to the other side. And now we have tan 3x equals 1 over root 3. We're not going to worry about the 3x now. We'll worry about it later. We're going to treat it like theta. So when is tan theta equals 1 over root 3? That's pi on 6. So you should have memorized your 1, 2, root 3 triangle by now. So from the previous page, we saw that for the tan x equals a, or in our case 3x, then the general solution is pi n plus inverse tan a. So our tan inverse 1 over root 3 is pi on 6. So our general solution should be that. But we have 3x. So 3x equals that. So what is x equal to? Then we have to divide both sides by 3. So we have pi n over 3. And we have pi on 6 dividing by 3 is 3 times 6 is 18. And we're going to join them to have a single denominator to make it look prettier. By multiplying this side by 6 over 6, we have 6 pi n plus pi over 18, where n is an integer. And we can further simplify by taking pi out as the common factor. Example 6, find the first 3 solutions to root 3 tan 3x equals 1. So in the first step, we'll do the same thing. We'll figure out what our general solution is. So we'll find a base angle to be pi on 6, and then we'll put it into our general solution of pi n plus pi on 6. And we make sure that we consider the 3x. So x will be dividing that by 3 and obtaining that general solution then. So this is exactly the same as example 5. But example 6 says find the first 3 solutions. Or in other words, when we let n equals 2, what's the first one? 0. So n equals 0 would give us 6 times 0, is 0 plus 1 pi on 18. And then the second solution would be when n is 1. So plug that in, we have 7 pi on 18. And the third solution is when n equals 2. So 12 plus 1 is equal to 13 pi over 18. And lastly, example 7, let's do the same question for the general solution, and this time using the CAS. So we're going to use main, interactive, equation inequality, solve, and we're going to replace something. Let me show you so that you're clear with this. It's a little bit confusing. So main, sometimes I use interactive, sometimes I use action. So you can use either. I like action. So action, equation inequality, and solve. So I can type in root 3, 10. So I go to trig for 10 in here. Then we have 3x close bracket equals 1. We can click enter, and you'll notice that there is this constant. All you have to do is replace that with the n letter. If you replace that section there with n, you will obtain the same thing. So that reads pi n over 3 plus pi over 18, which is the same thing as that. Okay, thank you for watching. I'll see you next time. Bye.